Cool. So Bash scripting. As you all should already be familiar, we've been going over through several command line interface challenges over these past few days. I say challenges, but I think I meant to say commands. We've been going over a lot of command line interface commands, and these are the very same commands that you're going to be using in a bash scripting context. One of the cool things about being able to script from bash is that it allows for the automation of otherwise manual tasks. And that's what the skilled DevOps engineer excels at, automating away any toil and manual tasks and saving themselves valuable and precious time. So let me also I got to pull up today's syllabus. I think just to make sure I'm not missing anything. Okay, right. We wanted to start off with some clarification on a few things, actually. So some definitions, some very basic definitions that we're going to need to know for our bash scripting. One of those very first definitions is a shebang, which is kind of like a mutated portmanteau of the word sharp and bang. The reason being, it's basically the hashtag symbol alongside a bang symbol. So shebang is this right here. It behaves somewhat like a comment. It's not actually executed at the start of a bash script. Instead, it's read as an instruction. We use the shebang followed by a path leading to, let's say, what we want to use to compile the instructions we pass in. And so if we're creating a bash script, we're going to pass in shebang and a path to our bash installed locally, which is a set of a folder inside the binary folder that contains all of the bash scripting logic and magic that we are going to be running. You can do the same with other shell, shell terminals, and you could do so with SH, with ZSH, should be able to do so with PowerShell even probably. And that essentially just tells the compiler what to use when interpreting the instructions we are passing in. Any questions so far? So why would you want to use bash scripting versus Python or JavaScript?
I guess it's probably more lightweight. Like installing Python is probably just another step that maybe doesn't need to happen if what you can accomplish doesn't need Python.
Definitely. Yeah, definitely. You're already in a shell environment when you're in the command line. You're already in an environment. And so you no longer need to rely on a heavy set of additional code to compile the commands that you are passing in. And so it is, like you say, lightweight. That's a good way of putting it. It's more easily accessible, and ultimately you'll be typing less lines of code, because if you want to call the same script from, let's say, your current location in a terminal, you will have to, well, you'll have to have like the necessary compilers installed. So for Python, you're going to need Python 3. For JavaScript, you will need Node. And additionally, when you work in these kind of languages, when it comes to, like, let's say, the CRUDing of files, manipulating data, that you're taking into memory from your terminal, there's a bit of extra legwork in importing the necessary modules or packages to handle these things, right? I think if you're already a little familiar with Python, you import OS so that you could read from the file system. Bash is pretty lightweight and most systems have it installed automatically. Exactly, it's readily available. Why go to the lengths of using additional code if it's not necessary? That said, if there's a lot of complexity to what you're doing, then yes, you may want to write out a Python script or a JavaScript, depending on what it is really. But the primary use case, I would say, for bash scripting is in responding or handling toil, for example. When you're a developer, you're focused on writing an application that really caters to a user, right? The end goal that you have in mind is to create an experience that is catered towards a user. So you have to kind of like pull out all the stops to impress them. Otherwise, they're going to stop using your app. They're going to leave, right? But when you're in, let's say, an enterprise professional working environment, who are your users? There are users to the organization, your customer base, sure, but there are also users within the organization. As DevOps, you're in a way providing customer service, not to users outside of the organization, but to users within. You're servicing other engineering teams. You're serving other developers. You're servicing stakeholders, folks that work in business or legal and compliance or security that may have automations they need to run in order to grab the files that they need in order to comply with whatever regulations are in place. And part of being an SRE or a DevOps engineer is setting up these automations and also responding to the failures that occur when these automations themselves fail, right? So that's going to involve a lot of manual tasks sometimes. You can do all of that from your command line, but if it's repetitive and there's a process to it, you could A, reduce that manual effort by creating a script that will repeatedly do this, and B, apply some error logging, some checks and validations to ensure that no mistakes are made, right? Because if a validation, or sorry, if an automation has already failed and you're responding to that failure, it would suck to make it even worse, right? So there are many benefits to using bash scripting, especially in a professional works in like internally, I would say, to the organization, whereas software development is more catered towards the external audience of an organization.
Julius, could you cite maybe an automation use case for bash? Maybe something you've created?
Sure. So let's say at work, maybe we'll get a request from somebody in like a compliance team. They need these NOAA files. Please don't ask me what NOAA stands for. I can't remember off the top of my head right now. It's compliance stuff, like really boring compliance stuff. And sometimes the automation fails, right? Like these are set to run on cron, and so they'll query a database or they'll query an S3 bucket somewhere for a result, and then they'll pull down the necessary files, right? Sometimes this fails, and we'll have to manually go into whatever server or node these exist in, and then we have to manually pull them down and upload them to whatever ticket we get so that the end user has access to them. What other use cases are there? SFTPs. We have bank files that we get from the banks that we work with to, confirm and acknowledge when transfers go through, right? Sometimes these automations fail. We'll have to manually SFTP onto the server, find the right directory, grab the acknowledgement file, move that back to our local machine, and again, attach it to whatever source we want to attach it to, email, Slack, usually a ticket. And we could just do this over and over and over again, or we can write an automation and just do it with a single command. Or better yet, if you have an orchestrator or a batch handler, out of sight, out of mind, set up the automation in place so that when these things happen, when the request comes into play, there's some kind of automatic action that happens that will resolve the issue for you, right? So for example, we have a tool, an internal tool that our team built at Innova called Shadow. The whole point is that it runs in the background. It's like totally unnoticed. How it works is it connects to endpoints created by the software engineers for their specific applications, right? And so users like customer reps, salespeople, they can make requests. Like, let's say if they need to change a loan status or cancel a payment record on a failed payment or ensure that an email goes out. We've already built out the automations that have automated these manual tasks, where in the past we would have to normally SSH onto the proper server for the proper brand, find the account based on the account ID or whatever information is passed to us, change the status through whatever method is built into that object, or we just have a self-service option where they have a front end they could use. They could say, oh, I need to change a loan status. I'm going to make this request. It hits our application called Shadow. It knows to route that information, that, let's say, user account or that loan status, to the right endpoint so that the actual logic that's in place in that application can do its thing. And it's completely out of sight, out of mind for us. When I first started at Innova, maybe we would get like a dozen tickets a week, 2 dozen, like when things got really bad. We would be told from time to time that like 5-10 years ago, SREs had to deal with hundreds of tickets a week. We get like 2 or 3 tickets now. It's pretty wild. Most of our time is spent on projects because we've been able to automate the toil away.
How big is your user base?
Let's see. So at OnDeck, it's a fintech company, right? So we have multiple brands. We have CashNet USA, NetCredit, OnDeck Capital, and OnDeck. It's just OnDeck and Headway Capital. And these are all separate teams of software engineers maintaining these large applications and dependencies and services. And it's not just the apps either that are customer facing, right? There's also the internal tools that we need for our teams to operate. And so a single brand consists of more than just the customer facing app. It's also the portals that the reps and the customer service folks use. It's also the additional tools like OnDeck, for example, is like the largest beast of all of these brands. It has so many dependencies. It utilizes Salesforce, which I'm pretty sure a lot of you have already heard of. It also utilizes on top of that a lot of built-in applications, things that are named silly stuff like Calico or Alpaca. We have to help the engineers maintain all of this stuff, right? And so to answer the question of how many users we have, it's, in a way, it's all of these software engineer teams, right? In a way, it's everybody in the contact center department, like all of those people, all the sales reps, all the customer facing folks, various stakeholders in the business. We have like an initiative going on at Innova where we basically have an SRE who is assigned as a captain to different software engineering teams. And we will work with them in ensuring that their technology is up to par with our standards. So like maintaining a certain number of service level objectives, knowing how to run incidents or report incidents when they happen, being able to know how to manage those incidents where every second counts, because every second that something major or critical has failed, we're losing money, right? So it's kind of hard to quantify exactly how many users we have. In a sense, it's a big part of the organization.
Yeah, for sure. Thanks. This is awesome. You sold me on Bash when you're in all of that. So let's do it.
Right on, let's do it. Okay, so we've talked about the pros and cons, maybe more so the pros of Bash scripting. But let's also talk about what goes into it. So we've talked about shebang, right? That's basically the thing that tells your system, your machine, how to interpret the code that you are passing in. Like a typical, I don't know if typical is the right word, but like a more complex programming language like JavaScript or Python, we can work with things like variables and loops and conditionals and operators. All of that stuff is available to you when you're scripting in Bash. Let's talk about data types. We have here in this example a very simple number as a data type. Or actually, it's saying that strings are the default data type in Bash, and most of the syntax is designed to support this main primitive data type. However, integers are supported as well for the times that this is useful. In this case, to interpret an expression mathematically, we use an arithmetic expression operator. We start with a dollar sign. A dollar sign will denote a kind of input. So if you see anything with a dollar sign, you can expect a user to be prompted for an input. With the two parentheses, I believe we can essentially pass in that input automatically. So in this case, yes, there's two sets of parentheses, and what it's going to do is it's going to process number 1 plus 10. In this example, we are reading from a predefined list, and we are using echo to print that out to command line. We have cases where we might need to rely on conditionals. So if here we're checking to see if the name equals user, or whatever is returned from this user variable, then we print out your name is your username. Otherwise, we do something else. Yes, the syntax is a little funky. Like we end the if statement with an fi. Very small things that are kind of unusual, but I guess every programming language has its own kind of quirks, right? So we're talking about conditionals, we're talking about different operators. Let's actually do something a little more exciting and see some of this live in action, because it's, I think, easier to see the benefit of this if we could see it live, right? So where are we? I'm going to make a directory. I'm going to call it Bash script demo. I'm going to make a new file, demo.sh. We're ending in sh because this is a shell script. We want to use our shebang, which is basically your sharp and a bang. And then we're going to pass in where my local bash is installed. So now we have a bash script. Let's start by saying what I want to create right now. I want to create a script that will create some basic files, or maybe we should start simpler. I don't know. Yeah, let's do an echo. Let's say echo hello world, because I think that's what the original exercise does. So now, before I can execute this script, what do I need to do? Somebody tell me, anyone.
Change the permissions.
Exactly. Let's run our, can somebody tell me how to do that?
Would you do the
Chmod, but
chmod plus X?
I don't remember exactly
And the numbers.
the
just
numbers. I
like-
don't remember that.
777.
4, 777. You could do that, or you could do like a U plus W or a read write execute. I like the numbers better though.
Okay.
Could we do the plus X just to make it executable?
Yes, we could do the plus X to just to make it executable. So let's do the plus X, and then we're going to pass in the name of the script. So demo.sh. And now we can say demo.sh. And we got a hello world. Let's do something a little more complex. Let's start by writing a function. I want to create a function that will generate some log files. I want to utilize a date. I'm going to utilize a date as the name of the log file. So as you see here, we have access to built-in shell script, I guess, methods, just the way that you would inside of like JavaScript or Python, right? If you were inside of a JavaScript environment like Node, you could type datetime.now to get the timestamp, the date and timestamp of the current moment. And let me say, oh, actually, right. I want to have user input. I want to ask the user for a specific date. So I'm going to do something like date equals 1. And I'm going to create a log file. So I need to create a variable for it. And I'm going to create a location for it as well. So let's say logs, and let's just put in a log folder. We're going to pull from this variable. So we are going to use the $sign to reference that. And we are going to make that the name of that's just going to be the name of the log. So this let's test it out right now, actually. This should ask me for an input. That's what this $1 is. And it will store what I pass in as a date, and then it will name this file based on that. So let's try running this again. Oh no. Oh, right. We have to actually call this method. So let's try generate log file. And we will pass in actually, I'm gonna just try by itself. I want to see what happens if we do it by itself. Oh no, just like that. I'm going to back up through my notes here a bit. And if anybody sees like anything wrong with my code, feel free to shout it out.
On line 12, do we need parentheses to call it?
Yeah, I was gonna say, do we need to echo? Or
oh yeah, that's a good call. We might actually want to echo what we're doing, right? So let's say let's do a confirmation. So we're gonna say echo log file. And now let's see what this does. Okay, so we're getting somewhere. We see that it's creating, or it's saying it's creating something. But I don't think the logic's not there yet for it to actually create anything. It's really just creating a string for a path. And it's not actually taking anything in yet for the date. So that's why it's just returning this path and then .log. So let's tweak this a bit. And let's say we want to calculate. Let's do a calculate method. There's already a date method that's built in, right? So we have access to the current date. What I'm trying to do here is create a number of different log files, one for every day. And the day that the user is prompted for, or the number that user is prompted for, is the number of days away from today's date. So let's say if I were to say 3, then it's going to create log files for today, yesterday, the day before, and 3 days before today. So that's my goal. So let's say the next thing we need is the number of days. That's what we're going to be prompting the user for. And then we're going to say the target date is, you have to be mindful of spaces inside of Bash, by the way. You may have noticed already if you tried to create an alias and you've used the space that it will fail. Bash is very particular about not having spaces before and after equal signs. Here we want to say date using the built-in date, not, and then we're gonna pass in a -v parameter. We're gonna say the number of days plus some characters to say it's going to be a year, month, date format. So let's now also see what that looks like. Oops. Ooh, there's something it doesn't like. It doesn't like how I'm using date. Minus number of days. Yeah, this is ugly and very hard to read. But let's continue to try to work through it. Let's see. We want to, maybe it's because we don't actually have a loop. Let's try a loop. In order to be able to create more than one log file based on the number of days that we're passing in, we're going to want to iterate through, or we're going to want to use a loop. So let's use a simple loop. And just like in JavaScript, we're going to start with an index that we start at 0. And then we're going to say while this index is less than the days prior, because we want the days prior to today's date, we're going to increment that index. Instead of a colon, we use a semicolon, and we then say do. We're going to indent. We're going to say the target date equals, we'll call the calculate date method here. Yes, I think this is what I'm missing. When I'm calling calculate date here, I am missing a parameter that it's requiring. So let's get rid of that, and we're going to keep this here. We're going to do a $i, and then we're going to do generate log. This is where we're going to call it generate log. And then we pass it the target date. So now we can comment that out, and then we're going to say done. And let's see, let's give ourselves a some kind of user-friendly message to prompt for what kind of data we need. So we want the number of days prior to today's date. And then we're going to assign this to days, or we're going to read days prior. So let's try this now. Okay, now it's asking for the, all right, sounds good. It's asking for the number of days prior to today's date. So let's just say 2. And it looks like it's created 2 logs. Today is the 3rd, so that's the 1st day. And then yesterday was 2nd, so that's the 2nd day. Let's actually take a look. Oh, so close, but not quite there. It looks like it's not creating the files just yet. Why is that? I wonder if it's because, unless somebody had a suggestion. It may be because we're missing this directory. Because if we look here, we don't have any folders called logs. So let's say we want to make this directory It's gonna be logs. Just logs. We'll just do that. Now let's try it. Now let's do 3. Let's do ls. Let's log in. Let's go into the logs folder. Let's do another ls. Oof, still no files. All right. Where is our bash script failing?
Is there any way to copy into the log, like move to the log once you get that log returned?
What do you mean move to the log?
Like a CP, and then because we just made it, we haven't really done anything to it, have we? Like we just made directory, but does that tell it to input anything into it?
No, it's not, is it? But
Do we perhaps like pass in the touch command somewhere? Like pass in the actual command to create the file in the function?
we could try that. Where would you put that?
I would think in so we're looping over and we're calling generate log file each time. So in the generate log file function, we might be able to touch somewhere in there. And then log file, so when we do log file, that's creating is that creating a string? So maybe we just touch log file.
Okay. All right, let's give that a shot. I'm going to cd up one directory. I'm going to run this script again. It's going to ask me for the number of days. I'm going to say 3. It says it's created it, but again, we already know now that that's just a string. So let's go into, ooh, what is log file? Let's open up log file once we type the name accurately. Well, it made a file. Let's see if we do that. ls. It made log file.log. So we're getting close, I think. One of the problems is it's still not creating it for every day that is prior to today, right? So we are expecting it to create, if I say two separate files, not just one. So let's get rid of these because that's not what we want. And let's take another look at our code.
Oh, what if we put on line 9 when we had touch log file? Does the $sign represent anything in front of it? If it was $log file
Let's give that a shot.
or not log file, without the .log.
I do have a
I'm not
quick question.
awful familiar with Bash. So does the $sign now reference the log file on line 7?
Yes, I believe it's going to read it as a string. And so it might name the file that entire string. And hope you will find out what it does exactly. And somebody else was speaking up, I think.
Sorry about that. I just had a question. That local keyword in front of the variables, is that alluding to the scope of the variable?
Yeah,
Okay. Thank you.
all right, let's. Three. There's a log file.log. And I'm pretty sure there's going to be nothing in here. Oh, it made logs. That wasn't there earlier, right? Let's, just for a sanity check,
Mm.
let's get rid of logs. Let's call this again.
I think it worked this time because we didn't make the log directory prior, so I think it didn't have a place to put it.
But we kind of made the log directory a few steps ago. And let's see what happens if we get rid of this, since we've. Oh, right, I'm in this directory, so let's do an rmrf logs. Let's also get rid of this because we don't need it. And now let's go ahead and call the script again. Say 3, let's do an ls, let's go to logs. And nothing. So using touch allowed us to create a log file. And it looks like using this $sign allowed us to access this variable, this local variable. And instead of reading the entire thing as just a string, it's actually treating it. I mean, it is, right? Because it knows to put the log based on the date into this logs folder. So let's try that one more time in the right directory. And let's do 5 this time. Let's into our logs folder. Ooh, that's some, oh, I didn't save. So let me, that's fine, leave my folder there. Let me try this again. Let's say 5. Let's go into logs, and we have our logs. It's slightly different from the code I had written earlier, but we definitely found a working solution together. Any questions on this?
So this is only creating the file with the date in it, right? But it's not importing anything into that file. Like those files are still empty, right?
Right, they are empty. Let's
Okay.
see. Let's go into these files. I was playing around with an API earlier called Fortune Cookie API, hoping to basically call the API, which should return Fortune, and unfortunately, I think the API stopped working. Let me grab that address. So if we go to Fortune Cookie API, yeah, this is what I wanted to use. But it seems to have stopped working. Or I might need, I didn't dive deep into it. It looks like I might actually need authentication in order to use it. So if I were to just curl this API, it just returns a lot of HTML. So that's what originally was inside of the bash script. So if we were to say full JSON response equals curl dash SS, that passed in. Oh, I think this needs to be parentheses. And let's logs. Let's call this again. Ooh. Do I keep forgetting to save? Okay, that took a little longer, so I'm thinking it worked. Oh, but it didn't. I might be missing one more thing. This is just gonna say in the terminal if we've gotten any kind of response. And let's say saved. Read that again. Call my script. Line 22 and 23.
I think on line 10 at the end, we're just missing a quote there.
Oh, thank you. We don't want what we do want. Oh, I see what I did. I looking at the wrong line. Right, this is just supposed to be the echo that's read inside of the command line. So we're going to say you want to pass in the JSON response. And now let's try it. Three days. Okay, it's now logging the curl response. And it is also passing the response into the file.
Can I ask a quick question real quick? What was the curl-ss doing?
Okay, yeah, curl is a way to make a request, right? Like a fetch request. And these two parameters, the lowercase s is for silent, so that we're not seeing like a bunch of things in the command line that we don't need to see. Capital S, blanking on that. We have the, let's see it without the capital S just to see what happens.
So it's just fetching an API call, just like Axios await.
Yeah,
Similar.
exactly.
Thank you.
So here, that's the response without the dash lowercase s and without the capital S. Very long response. I cleared out my terminal.
Is sleep the same as Python if you want your script to like pause in the middle of it or basically wait?
Let's see. In the context of bash scripting, or
Yeah, bash scripting. I was thinking of like a way to simplify like some scraping logic, because you could probably like curl and pipe the HTML that you want to like scrape, and then use sleep to not have it do like too many requests at one time.
let's give that a shot. So let's say sleep 10. Let's call our script. Looks like it's sleeping.
Cool.
All right, there's our first response. Should be sleeping again.
And that's for each second, so 10 was 10 seconds.
Okay, I had to look it up because I forgot, but the capital S in the dash SS is for showing an error. So yeah, the first one is for silent, and the second one is to show the error. Any other questions? Cool. So today's challenges are going to be basic bash scripting. I believe this is actually an external exercise. We're going to run through, this will familiarize you with like just a lot of these. So no need to push solutions to this one, but I definitely want to see solutions for this. I think this will be interesting and fun to watch. So it's just like the first two challenges on the first day. We have 99 bottles and we have Def Grandma, but instead of writing it in Python, you're going to be writing it with a bash script. Cool. All right. I will open out breakout rooms and we can all step away for like a 15-minute break. And when you get back, you could just jump into one of the rooms.